This is a very pretty Sansui AU-717. Unfortunately, the volume potentiometer on this unit is broken. Not only does it rotate freely with no end stop, but it also fails to pass the left channel. The left channel comes in, but it never leaves. After looking at some threads online, it turns out that this potentiometer is a relatively common failure mode with this model, and finding replacements is practically impossible. Fortunately, we can still use this as an amplifier. So my plan is to rebuild the power supply, which is all original, as well as both amplifier modules, which are also all original, and then test. Let's take a peek inside before we get started. Each channel has its own transformer, as well as its own pair of bulk capacitors. This is the power supply board, and these are the individual amplifier modules. I'm going to start with the power supply, so let's figure out how to get this out of the unit. I'll be starting from the top of the amplifier, and we have 3 cable sets to remove, here, here, and here. Fortunately, the left and right sets don't need to be marked in any way as long as you take a good photo of each. The center set does need to be marked though. The 2 reds do not go together, neither do the 2 whites. You can see I've distinguished them by drawing a little black line on each. I'm going to start desoldering. I've disconnected all 3 cable sets from the top. Let's see what we have to do on the bottom. On the bottom, some of the wires have connectors. Those will just slide right off. But there are still many wires that need to be desoldered. Fortunately, down here, all of these wire colors seem to be distinct. So as long as you take good photos, you shouldn't need to worry about reassembly. Here's the power supply. Let's see what kind of work we might want to do while it's out. At a minimum, all of the electrolytics are going to be replaced. There are a bunch of these, and yes, most of them probably still are good, especially the bigger ones. But if you want this unit to last another 30, 40, 50 years, it's a good idea to replace those. So those are on order. The relay looks to be in pretty good condition. I know that it still does work, but this is the original. The contacts can become corroded and pitted over time, and I don't know if I can service this very easily, so I'm just going to replace that as well. I happen to have a good replacement here. I'll also pull all 4 of these transistors that are mounted to the heat sinks, clean and reapply new thermal compound. And there is a bit of a problem on this board. Let's zoom in. All of these larger capacitors were glued down to the board for support, which is fine. Except over time the glue starts to eat away at whatever it touches. Take a look at that Zener diode. Both legs are almost fully corroded. As soon as that corrosion hits the actual component, it's going to fail. Similar over here, that resistor, the resistor below it, there's a few other components. And the same goes for the other side. We have some components starting to be eaten away at. And I did think this was all original, but it looks like this Zener was replaced at one point, just a single component. Interesting. So I'm going to replace anything that has corrosion on its legs, including a few resistors on either side, both of those Zeners, and anything else that I might find. If you use this specific relay as a replacement, you will have to clip these 2 legs. They're not needed, and there's no holes on the board for those. I removed the 5 capacitors that were glued down in this area. Let's zoom in and take a closer look at the damage. Plenty of components right on the edge of failure. Looks like these 2 resistors are the closest. So I'm going to remove all of these affected components, remove the glue, and then we can install the new components. I'm sure there are other effective methods out there. What works for me is I like to heat up the glue a little bit with my heat gun and then carefully scrape it away with something like a flathead screwdriver. Takes time, but it's pretty effective. Well, that was a lot of work, but there's no shortcut, folks. All the glue has been removed. I'll do the same thing to this left side, and then I can install the new capacitors, resistors, and diodes. Here's the final product. A note on potential improvements. These 4 capacitors, 23, 24, 25, and 26, these are the smoothing capacitors for the plus and minus 33 volt rail for each channel. The originals were 100 microfarad at 35 volts, and that 35 volt rating is just too close to the 33 volts it's trying to smooth, so I'd recommend improving those to 50 volts. All right, let's get this installed and test. All right, it's the moment of truth. I'll power it on and we'll make sure it comes out of protection. Sure does. Fantastic. Let's verify the voltages of this power supply. We'll start with the low voltage rails. According to the schematic, something like plus or minus 33 volts. They're not going to be exact. This one is minus 34, and this one's plus 34.4. Those are okay. Let's check the other channel. Over here we have plus 35 and minus 34.2. Those are just fine. Let's move on to the high voltage rails. And the schematic says these should be somewhere around plus or minus 56 volts. Minus 57. Plus 57. Let's move to the other side. Over here we have minus 57.3 and plus 57.2. Fantastic. And that'll do it for the power supply for the Sansui AU-717. I think it turned out really nice. Join me next time where we'll take a look at both amplifier boards and bring those up to speed as well. I've also spent a bit of time analyzing the power supply schematic for this unit. And if there's any interest, let me know in the comments and maybe I'll make a separate video on that. Thanks for watching.